Are you having problems with your wood? Do you look at your piles of biomass outside and wonder, whatever can I do with all this poorly compacted biological material? And struggling and suffering to rip and tear at your biomass leads nowhere but frustration and splinters. Millions of people just like you struggle from this same dilemma, unable to use this biomass for a helpful purpose, such as turning them into compact briquettes for the whole family to enjoy. If only there was a way for your biomass to be pulverized into a fine powder in mere seconds in a cheap and portable fashion. Sticks and stones may break your bones, but too many sticks and leaves can cause you griefs. Introducing the Marlboro Shreds Mako.
Currently, more than 750 million people worldwide lack access to electricity. This number is growing at an increasingly alarming rate, especially in the middle of sub-Saharan Africa. And in order to combat this increase in people without this energy, we focused on providing some sort of sustainable power to the people living off-grid. And the way we did this was by utilizing what they had readily available, which was their biomass, such as twigs, wood, and leaves, as fuel sources. For designing a machine that could provide the energy needed, we would have to be able to produce fuel, do so automatically, have some sort of portability, and cost a reasonable price.
For our final design, the motor we used was a 1/3 horsepower electric motor capable of running at 1750 RPM, which we ran at about a 2-to-1 gear ratio, giving us a faster speed for our cutting blades. The motor uses 115 volts at 7 amps, giving us 800 watts of power consumption. Through testing, we found the total throughput of biomass was around 6.75 kilograms per hour, or about 1.875 grams per second.
The shredder design we ended up making was a single shaft shredder with a chute adjacent to the blades with a 45-degree angle. This gives an open slot to insert items like wood and other forms of biomass. Overall, the frame was made out of unistrut and connected using brackets and bolts. For the shredder itself, the blades were angle grinder blades. We found that using these gave really fine sawdust that is the right size. Within the design, we have 5 blades with a total of 4 washers in between each blade. This gave the blades enough space to efficiently operate and cut without leaving gaps in between the blades. The shaft is a 5/8 inch steel threaded rod. This ensures that the blades are replaceable. The shaft is held onto the frame using 2 bearings. With these bearings, they are attached to the unistrut and holes were drilled to ensure the clearance of the shaft. There is an emergency stop button to ensure safety and the shredder is not on by accident when plugging it in. This is attached to the top of the housing. The housing of the shredder is made from steel sheet metal. There are a total of 5 steel sheets of metal that were bent precisely and have holes drilled or plasma cut to allow bolts or the shaft through the housing, but keeps the sawdust or pieces of biomass flying away from the shredder. In order for the blades to turn, we have a chain with 2 sprockets attached to the motor and the shaft, gearing it up from a 15th tooth sprocket on the motor to a 9-tooth sprocket on the shaft. This makes the speed of the shaft go up, which helps due to the design of the blade.
When it comes to future work, the first problem that needs to be improved upon are the set screws. With the current design, the set screws become loose from vibrations, allowing the sprocket gears to become detached. Replacing the set screws with keys will help prevent this from happening and make for a more reliable way to transfer the torque from the motor to the blades. The next improvement were to be add legs to the final design. This would allow for a better system of collecting the shredded material to be installed. As of currently, the machine sits on the ground and all the shredded material falls straight to the floor. The legs would also help in reducing vibrations and make for a more stable platform. The final product will also need a frame that is changed from the unistrut to a custom built. This will allow for better attachments for the motor and bearings, as we will not have to use the custom holes in the unistrut that is already there. This will also help with reducing the gap between the blades and the frame, as small material is able to get sucked in currently and stall out the motor. This will allow for smaller materials to be cut when the blades are moved closer to a custom frame. The final change that needs to be made is to increase the length and angle that the feed chute goes into the machine. As of currently, smaller material is able to get launched out from the fast-moving blades. By making it at a steeper angle, gravity will help keep the material from bouncing out and let lighter materials be shredded up.